Now, so far what we've done, three routers run the single area OSPF, which is area 0. So, and then the router IDs, Johannesburg is 1.1.1.1, Cape Town 2.2.2.2, and then Durban is 3.3.3. So today we just expand our topology. So we're going to add Pretoria, and then we're going to add Bloemfontein, and then we reorganize into 3 OSPF areas. Area 0, which is our backbone WAN, and then area 1, which is Johannesburg and Pretoria, and then area 2, which is Cape Town. Durban remains in area 0 as a subsite, right? And then Johannesburg just becomes the ABR connecting area 0 and area 1. So it's ABR meaning the area border, basically the area border router. Now, here's the problem with the big OSPF area. Previously, in the previous lesson, we configured the single area OSPF, and it worked beautiful for our three site network. So today our company is growing. All right, so we are adding Pretoria office and then Bloemfontein office, and as we grow, we hit the limit of a single area OSPF. So let me explain the problem. See, in the single area OSPF, every router in the network floods the LSA, the link state advertisements, just to every other router. So every topology change anywhere in the network forces every router to rerun the SPF algorithm. So with 3 routers, that is fine, but with 50 routers, like maybe a very large enterprise, it is a serious problem. So problem number 1 is the LSA flooding overhead. So every router just sends LSA describing its links. So in a 50 router single area, each router must just store and process LSAs from all 50 routers, and then the LSDB grows enormous, and then the memory and the CPU on every other router are consumed just maintaining OSPF state. And then problem number 2 is that SPF recalculation storms. So every time any link anywhere in the area changes the state, maybe a port flaps or a cable is bumped, every single router reruns the full SPF algorithm. So in a large flat area, a poorly connected access router in Cape Town causes maybe SPF recalculation on the core router in Johannesburg, even though the change has nothing to do with Johannesburg. And then problem number 3 is that routing table size, because every router learns every subnet in the area as a separate route. So 50 routers with 3 subnet each, 150 entries in every routing table. So a multi-area OSPF with a route summarization can reduce this to a handful of summary routes at the area boundaries. Now the multi-area OSPF solves all 3 problems by dividing the network into smaller areas. LSA flooding is contained within each area, and then a change in area 1 only causes the SPF recalculation in area 1 routers, and then routers in area 2 are shielded from it. And then route summarization at the area boundaries just reduces routing table size, so the network becomes scalable to thousands of routers. Let me give you an analogy. So think of the 9 provinces that we have. Each province manages its own internal affairs, like road maintenance, schools, hospitals, potholes, crises. Let's say the potholes crisis in Limpopo does not require the Western Cape government to recalculate the entire budget. You understand? But all provinces connect to the national government in Pretoria, which is area 1, area 0 backbone. And then OSPF areas work exactly the same way. So each area manages its own topology internal, but all areas just connect to area 0 backbone. Now, the most important role in multi-area OSPF is that all non-zero areas must connect directly to area 0. Now, area 0 is a backbone, no exceptions. So you cannot have area 1 connect to area 2 without going through area 0. So if you have maybe a non-backbone area that cannot directly connect to area 0, you use a virtual link. But that is just an advanced topic beyond the scope of this lesson. Now, the area border router is the router that belongs to the 2 or more OSPF areas simultaneously. So one of those areas must be area 0, and then the ABR, or the area border router, maintains a separate LSDB for each area it belongs to. So the ABR's critical job is just to translate the routing information between areas using type 3 summary LSAs. So when area 1 routers learn about subnets in area 1, then the ABR creates a summary LSAs describing those subnets and flags them into area 0. And then routers in the area 0 and other areas learn about area 1 subnets through these summaries LSAs, but they do not need to know the detailed internal topology of area 1. So in our network, the Johannesburg router will be the ABR between area 0 backbone and area 1, so meaning Johannesburg and Pretoria. And then it will also be ABR if we add more areas. And then Cape Town will be ABR between area 0 and area 2, which is Cape Town and Bloemfontein. There are LSA types that you must know. There's type 1 that is generated by every OSPF router, and then is flooded within its own area only. So basically just describes the router's own links and neighbors. And then there's type 2, which is a network LSA. So this is generated by the DR on multi-access segments. So then it's flooded within its own area only as well. So it describes all routers on the broadcast segment. And then type 3 is generated by the ABR into adjacent areas. So it just advertises subnets from one area into another area. And then type 4 is generated by the ABR as well, and then it's flooded into adjacent areas. It tells the other areas where the ASBR is located. In type 5, just an external LSA is generated by ASBR, so and it's flooded to the entire OSPF domain. So it advertises router from outside OSPF. And then, for this lesson, the most important is type 1, the router LSA, which stays within its area, and type 3, which is summary LSA, which crosses area boundaries. So when you see maybe IA in the routing table next to the OSPF route, that means that it's an inter-area. So it's learned via a type 3 summary LSA from an ABR. And then O without an IA just means that the route is within the same area. Now, the route summarization, also called route aggregation, is one of the biggest benefits of the multi-area OSPF. So instead of advertising every individual subnet from area 1 into area 0, the ABR can advertise a single summary route that covers all of them. For example, area 1 contains 10.10.1.0/24 and then 10.10.2.0/24 and then 10.10.3.0/24 and then 10.10.6.0/24. So that will be Pretoria, right, that we're going to add now. Instead of flooding our type 3 LSA into area 0, the ABR can advertise one summary. Now 10.10.0.0/16, it's going to be covering all our 10.10 addresses, and then routers in area 0 and area 2 only need one route instead of 4. So the benefits is that smaller routing tables on all routers, less memory and CPU, and then the topology change inside area 1 only triggers SPF in area 1. So the summary route advertised into area 0 does not change. So area 0 and area 2 routers are completely unaffected. So this is a key scalability win, but there are risks. The risk is that summarization can sometimes cause suboptimal routing if not designed carefully. Now, a summary that is too broad may match traffic destined for addresses that do not exist, and then that thus causing the black holes. You know, always summarize on natural boundaries that match your actual address space.